Applied Energy Research.
So what is the Center for Applied Energy Research, and what is your role in working here?
I am a research engineer, and my work directly supports the science being done here. And the Center for Applied Energy Research is it's under the Vice President of Research, and it does energy-related research. Started off as a coal to liquids research facility, and now has grown into carbon fibers, carbon materials, carbon nanotubes, CO2 sequestration using algae, chemical sequestration of CO2, among other things. So just energy-related research in general.
Are there any projects that you're working on right now in relation to the biofuels?
In relation to biofuels, it's kind of subtly related. The project that I work on primarily is funded by the state of Kentucky Department for Energy Development and Independence, and it's investigating the technological and economic feasibility of using microalgae to mitigate the carbon that's coming out of the CO2 emissions of power plants. And how that ties into biofuels is that the vast amount of energy produced by coal power, the coal used to burn it, to produce it, emits a large amount of CO2. And that CO2 can support a large amount of algae growth, and algae biomass can then be used for upgrading into biofuels.
How would this research be beneficial for Kentucky?
In multifaceted, it would help, I guess, ensure the future of the coal energy industry. In case a CO2 tax comes through, that would basically put the cost of doing business for the coal utilities would go up, and they would have no choice but to pass that on to the consumer. So the consumer, being you and me, and big consumers like Toyota and the aluminum industry, their rates would go up, and some of the heavy industry that rely on low energy costs could leave. So if we can mitigate the CO2 emissions using algae, it would actually prove to provide a value stream at the end of the process that can help offset the cost of the carbon capture, generate a revenue stream back to the utility, and provide Kentucky, the Commonwealth, to be well placed in renewable fuels.
So what are the short-term and long-term goals for biofuel technology?
As far as I know, the short-term goals for biofuels is to move from a biodiesel-based or a corn-based ethanol fuel to a fuel that is more chemically compatible with the gasoline, the diesel fuels that we use now. Moving from, I guess, first generation biofuels to second generation biofuels. And that would be a short-term goal. And long-term goal is to move away from food-based sources of biomass for the biofuels. And so being able to tie this project in with the other research going on here would prove an asset.
Can you see biofuels as a practical way to replace petroleum in cars? And if so, by when?
Short term, no. And it's just a function of how much petroleum we use and the efficiencies current and the state of the art in the biofuels industries. Long term, I hope so. But it's really the scale of the problem, and the easiest way to make an impact on that would be to drive your car less, to not speed as much, to drive smaller cars, to have more efficient engines, and that would really be the way to reduce dependence on foreign oil. But biofuels they can make a dent, they can help contribute, but are not poised, it's not mature enough to replace petroleum. So I actually don't see a future where we are not using petroleum in the next 50 to 100 years.
So how can biofuels be used now without any big changes in infrastructure and engines?
The second generation biofuels that I alluded to earlier, diesel that would just go right in your car. The other emerging area of research is pyrolysis, where you actually take the whole biomass and create a what's called a biocrude, and that's essentially very similar to a barrel of crude oil. So now you take this pyrolysis oil and you put it directly in the refining chain. So rather than a barrel of crude oil that got pumped out of the ground, this is a barrel of crude oil that was produced using biomass. And then we leverage the experience and the success we've had in our refining industry. And you also don't find yourself competing with Exxon and Mobil and Shell. You're actually doing business with them and supplying them, but providing a more renewable kind of feedstock to that system.
Can you tell me a little bit about what's behind you?
This is what's called a photobioreactor. It's a fancy way of saying a place where algae grow. We use clear tubes. They're fairly thin and they're made out of the same material that Coke bottles are made out of. We essentially are using a photobioreactor in order to make the most efficient use of the carbon dioxide in flue gas emissions. So typical atmospheric CO2 concentrations are around 0.03%. Typical CO2 concentrations in a flue gas from a power plant are anywhere from 10 to 20%. And the specific project now is 12%. So that's a couple orders of magnitude higher amounts of CO2. And seeing that CO2 is a reactant in the photosynthetic biochemical reaction, the processes that plants, including algae, use to grow, then the more CO2, technically, the more algae you can grow.
All right.